so let's start by just reviewing what we did Friday. I know several of you weren't here on Friday, so this will be a really good review for you. There is a video, part 1 of this, and this video is going to be part 2. So turn to problem number 8, and you notice that is a calculator problem. And we see on this that we have grams of a radioactive substance decomposing. This is how you know this is going to be one of those exponential growth, or in this case, decay problems. And you got to start with that equation. They're not going to give it to you, you have to know it. But if you know this equation and you have good algebra skills, you can solve the rest of this problem pretty easily. So if 40 grams is decomposing to 31.3 grams, which one of these is the Y value, which would be the current or the final amount? 40 or the 31? Which one should replace Y? The 31. Because the initial amount would be 40, and then for T would be the time right here, 2 years. Okay, now you have to solve for K. These problems are always pretty much 2-part problems. You need to get K by itself. And so the first thing that you are going to the solver feature doesn't work very well with this for whatever reason, okay? You could graph these two and find the intersection. I think it's really not that hard to say, oh, let's divide by that number. And then how would we get rid of the E? Natural log. So in other words, 2 times K, or 2K, would equal natural log of this 31.3 over 40. And then you would just divide by 2. Now, this is something if you're great at memorizing, I would memorize it. Your K is always going to be your natural log of the current value or the final amount over the initial amount, that whole thing divided by the time it takes for that to happen. It's kind of like with half-lives, you do natural log of 1/2 divided by what the half-life is. So this is something you're going to want to plug into your calculator. And so I'm going to go ahead and type that in. And it is going to be a messy number, and that's okay. Make sure that divide by 2 is not part of your natural log. It needs, what's written right here needs to look exactly what you have. And so I get this negative 0.123. Those of you that came in were on day 8, a couple people, and on the back. All right, now negative 0.123 is just an estimate. I want the actual number. Like when I go into part 2 of this problem, I need to use the actual K. So how can I do that? You're going to store it. So you're going to come down here above the on button, hit the store, and hit alpha K. And if you notice, there's actually a lot more decimal places to this, and that means you just have more and more accuracy. Sometimes this really won't matter too much, but a lot of times it will mean the difference between a right and a wrong answer. So you need to store it when you're using K. All right, now part 2 of this is answering the question. To the nearest gram, and there's some typos here, there's some words left out. But basically, after 5 years, what's left? So what's the Y value? So again, we have our current amount, or initial amount of 40. We have our K now is stored to that value, and our T is 5. Now, if you're trying to solve for T, you're going to have to do what we did over here in the red, meaning you're going to have to divide, take natural log, divide again, and all that. But this is just type that into the home screen, 40e to the power of K times 5. Oh, I did the wrong E. Or I did something wrong. Alpha K. Oh, I just didn't touch the alpha part. There we go. And so I get 21.66, and the directions say to the nearest gram. So my answer should be C, 22. These really aren't, they're not really calculus problems. They do have to do with calculus, but you're not doing derivatives, you're not doing integrals. And these are ones that I know you guys can get right. You just have to know this equation right there. You got to know that. Okay. So let's look at, turn back to the front to problem number 3. All right, so in order to do this problem, we've got to remember a few things. First of all, when we're talking about something, it's probably going to help to graph these, okay? May not be necessary, but if you get any kind of confusion, graphing will probably clear up your confusion. Okay, you also need to know, like when you're doing area, you can choose with respect to x, with respect to y, whichever one is easier. But if you're ever doing volume, you have to do what they tell you to do. So if the cross sections are perpendicular to the y-axis, that means you are with respect to y. If it was perpendicular to the x-axis, it would be with respect to x. And then we have a square. So I'm going to go ahead and write a equals s squared. So my volume is going to be, if it's with respect to y, my bounds are going to be bottom to top, y values. And my equations, or my slice, or my side, or whatever you're going to want to call it, is going to be right minus left, and I'm going to square that because it's a square. And then dy. So if this was just asking for the area, I would not need the square. But since it's asking for the volume, you have to incorporate that s squared. What else would I need if I was doing, say, semicircles? How can you modify what I've written here to semicircles? I could use half r squared, although that's more complicated than just using pi over 8 s squared. All right. Equilateral triangles, what would you need in the front? Root 3 over 4. Okay. So like moving forward, we need to find this stuff. And I'm looking at this, and if this is supposed to be with respect to y, I need my equations to be x equals. All right, and so this is not maybe your typical problem. So what do? We graph. Okay, so I'm going to go off to the side over here, and I'm going to graph. And so y equals 2. Okay, that's easy to graph. That's just a horizontal line. Okay, as far as this is concerned, if you're not sure how to graph that, you can either solve for y and use parent functions, or you could just plug in numbers like in a table and figure it out. So if I plug 0 in for x, then y should be 0. If I plug 1 in for x, well, that doesn't really help me too much. But if I plug 2 in for x, 2 squared, what should y equal? 1. And if I plug -2, I should get that same value. Remember, this doesn't have to be perfect. It's really just there to kind of give you an idea of what that base looks like. So this problem would be a lot easier if they had said with respect to x. I mean, this problem is totally set up to do with respect to x. But because they tell us perpendicular to the y-axis, I've got to comply with that. So that means, well, first of all, what are my bounds? Now looking at the picture, it's a little bit easier. 0 to 2. And then my right minus my left. What they're talking about here is this equation minus this equation. So I've got to, and I'm going to do this down here, I need to take 4y equals x squared, and I need to just get x by itself. So that would mean square rooting. So this is, I'm going to do a plus minus root 4y. So this side over here is going to be x equals positive root 4y. And over here, it would be x equals negative root 4y. This is the harder part about this problem, is having to change up your equations. It would have been nicer if they just gave us those. And you could have solved your bounds, by the way, by trying to, well, you're not really, never mind, I'm not going to go there. All right, so right would be root 4y minus left would be negative root 4y. So are y'all okay with me writing plus root 4y? The same as minus minus. And then from here, you plug it into your calculator. Okay? You probably could solve this by hand, but if you get to use the calculator, which you can on this one, you don't want to risk the chance of making a mistake. So go ahead and plug this into your calculator and see if you can figure out which one is the answer.
Was this yesterday?
All right, everybody, let's bring it back to this. Lots going on in the world. So here's the thing that I want to, if you're still working, keep working. If you're like, you don't have your calculator or whatever, look here. What I did here was, I didn't do this on purpose. I'm having a really off day today. My second period can attest to this more than any other. I just forgot the 4 right here, but I got 18. It's really easy to make this mistake. I'm really glad 18 wasn't an answer choice. Don't just pick the closest answer. Go back and think, did I make a mistake? You know? It's really easy for that kind of stuff to happen. Like, I get it. 32 is the correct answer. Okay, some of these are multiple choice, and all you have to do is set up the integral. The nice thing about that is, like once you find 0 to 2, you could probably cross off a couple of answers. By has to be in our problem. Maybe there's a bx answer that you could cross off. Sometimes people on these problems think that this is a washer or a circle problem. Those problems, we're going to review that in a minute. Those have pi in them. A volume with cross sections, though, should not have pi unless your cross sections are semicircles. All right, and so those are ways that you could narrow down the answer choice. And so what I mean by this is looking at number 6. See how a couple of the answer choices have pi? Once you determine if your answer should have pi or not, then you're either now out of 2 or out of 3. Okay, some of these say dx, some of these say dy. Sometimes that's all you need to answer the question. Not always, but sometimes. You can narrow it down just based off that.